So what we are going to talk about today is basically um, the Koyck approach to distributed lag models. Now, if we talk about the distributed lag models, then the distributed lag models are basically in the form of yt equals to alpha plus beta 0 xt plus beta 1 xt minus 1 plus beta 2 xt minus 2 plus it goes up. Suppose it is an infinite lag model. That means we don't know about the lags or about how many lags are present in the model. So in that type of cases, it is very difficult to estimate the beta coefficients because we don't have any certainty about the lags present in the model, and as we don't have any certainty about the lags present in the model, so we don't have any certainty about how many betas we have to estimate. So basically this process is very hectic to calculate this amount of betas. So what we basically do here, Koyck has proposed a very effective method to calculate the betas. Koyck has said that we will take beta k equals to beta 0, which is the beta 0 is nothing but it is the um, coefficient of the initial explanatory variable. That means if you see, this is the value of beta 0. So beta 0 into lambda to the power k. Now this k is going to continue from 0 to 1 and it will go up. Now the concept is here, if we have to estimate beta 1, it is going to depend on beta 0, it is going to depend on lambda, it is going to depend on k, right? So suppose if I have to calculate beta 1, then in the place of k I have to just put 1, so it will be beta 0 into lambda. If I have to calculate beta 2, it will be beta 0 into lambda square, right? If I have to calculate beta 3, it will be beta 0 into lambda cube, right? So basically what is happening here, we can represent all the betas with the help of beta zeros, or we can represent all the coefficients with the help of beta 0. Now the question here arising that what is lambda. Lambda is basically called rate of decline or rate of decay, or you may call it rate of decline or rate of decay. Rate of decay. And if we tell about 1 minus lambda, that is the speed of adjustment. I am going to explain it later, but now the question is that suppose we have some values of lambda, and let me show you something. Suppose the values of lambda are closer to 1. Suppose the values of lambda are 0.75, right? Then what will be beta 0? Well, beta 0 doesn't have any lambda assigned to it, so beta 0 will be beta 0. Now if we talk about, as you can see, beta 0 is not related to lambda. I mean if we talk about beta 0, then beta 0 will be beta 0, because if you put 0 in place of k, it will be beta 0 and beta 0 into lambda to the power 0, something to the power 0 is 1, so beta 0 is beta 0, it is not depending upon lambda. Now if lambda equals to 0.75, then what am I talking here is basically what will be the value of beta 1. Can you tell me what will be the value of beta 1 here? Basically beta 1 is nothing but lambda into beta 0, right? As we have seen it from here, from the previous part or from the previous slide, that beta 1 is nothing but lambda into beta 0, right? So as I can see, beta 0 into lambda, so I will write it as beta lambda into beta 0, same thing. So it can be written as 0.75 into beta 0, right? Now how can I write beta 2? Now as you can see from the previous slide that beta 2 is nothing but beta 0 into lambda square. So I can write it as beta 0 into lambda square. Here lambda is nothing but 0.75. Okay, and if I calculate 0.75 into 0.75, that is 0.75 square. So that will be basically 75s and 5s are 375. So we will take 5 and 37, and 75 into 7 is so 75 into 5 is 75 into 7 is 525, and we have 32 in our hand, so we will basically have 557. And what will be the point will come before 4 steps, so it will be 0.5575, or we may take it as 0.56. So basically we may take it as 0.56 into beta 0. So as you can see, if we go to beta 3 or if we go to beta 4, or then if we continue going like this, then what is happening here, the values or the weights given to beta zeros, or basically at first 0.75 was multiplied with beta 0, so this value is greater. Then so beta 1, in case of beta 1 it is 0.75 into beta 0, in case of beta 2 it is 0.56 into beta 0, right? So which one is smaller? Obviously beta 1 is smaller. So by this process, if we go up to beta 3 and beta 4, then the values will be smaller than the previous ones. Okay, so beta 1 is the beta 0 is basically the largest, and then beta 1 has lesser value than beta 0, beta 2 has lesser value than beta 1. It will be lesser and lesser and lesser. Okay, now if I talk about that, if the lambda, what is happening here, let me tell you. Let me erase it. If lambda equals to, suppose, close to 0, that is 0.25, then as you can see beta 0 will be beta 0, but what about beta 1? Beta 1 will be 0.25 into beta 0. What will be beta 2? If you calculate beta 2, it will be around 0.06 beta 0. So as you can see, in the case where lambda is closer to 0, the value of the betas or the value of the coefficients are actually the impacts of the coefficients are gradually falling, right, and falling very intensively. In this case where lambda was close to 1, betas were falling, betas were gradually declining, but not that much high rate, not in that much high rate. But in this case where beta is close to 0, the lambda is close to 0, betas are falling at a high rate. At first it was 0.25 into beta 0, then beta 2 is 0.06 into beta 0. So eventually if we calculate beta 3, beta 4, there will be almost no effect of beta 5, beta 6 or beta 7 or beta 8 or beta 9, beta 10. So basically what is happening here, that if lambda is close to 1, then we have to remember that if lambda is close to 1, or if lambda equals to 1, let me show it to you. If lambda equals to 1, then what is the value of the concept? If lambda equals to 1, then if I am estimating, suppose beta 5, right, and if lambda equals to 1, so beta 5 will be also equal to beta 0, right? So beta 5 is not like beta 5 is has changed a lot. I mean beta 5 hasn't decreased, or the rate of decay is very less. I mean it hasn't decayed a single portion or single unit. There is no difference between beta 5 and beta 0 if lambda equals to 1, right? Now So as you can see from the table also, if lambda is getting closer to 1, the betas are falling or betas are decreasing, but at a very slow rate, right? At first it is decreasing by 0.75, but then by 0.56. But if lambda is 0 or lambda is close to 0, then what is happening? If lambda equals to 0, then as you can see from the equation, then suppose I want to calculate beta 5 and lambda equals to 0, then beta 5 will be equals to 0, right? That means beta 5 has no value actually, right? If lambda equals to 0, then beta 5 or beta 6 or beta 7 has no value. That means those lagged variables have no effect on the dependent variable. If we calculate, suppose if I want to extend this model, and let me write this model in a little bit extensive form. Suppose it will be beta 3 xt minus 3 plus beta 4 xt minus 4 plus ut. Now the question is, as you can see, if beta 5, let me add beta 5 also. If beta 5 equals to 0, then that means xt minus 5, this lagged variable has no influence or no effect on yt, right? So that is the concept of the lambda. Now if I want to write the model into the general form, at first let me show you the summation of beta k. Now summation beta k is nothing but beta 0, right? Now we all know what we have written in the place of beta. Beta k is beta 0 into lambda to the power k. So let me write it. So we should write this in the beginning. Beta k equals to beta 0 into lambda to the power k, right? Now what will be summation beta k? Summation beta k will be the sum of all betas. That means starting from beta 0 plus beta 1. In place of beta 1, here k is ranging from 0 to infinity, that we have to remember. So in place of this, I am writing lambda to the power 0, then I am writing lambda to the power 1, then I am writing beta, this is beta 1, sorry, no, this is beta 0, sorry, this is beta 0, because beta 0 is common in the equation, right? Then beta 0 into lambda square, and it will go up like that, and it will end up in beta n into lambda to the power n, right? So if I take beta 0 common out of all this, then we will have lambda to the power 0, that is nothing but 1. I can write 1 in place of this, I can write 1 in place of this. So 1 plus we have lambda here, we have lambda square, and it will continue up to lambda to the power n. This is nothing but an infinity series, and infinity series can be expressed as 1 by 1 minus lambda. That means here it is an infinite series of lambda, so it can be expressed as 1 by 1 minus lambda. So I can write it as beta 0 into 1 by 1 minus lambda. Okay, so that's how we can actually represent it. Now if I want to express yt in this form, then yt was nothing but yt, as I have already expressed it also. As you can see, yt was nothing but alpha plus beta 0 xt plus beta 1 xt minus 1 plus beta 2 xt minus 2, beta 3 xt minus 3 plus beta 4 xt minus 4 plus beta 5 xt minus 5 plus ut. Now as we are talking about this, we are going to represent these betas by the help of beta 0. That means I am going to represent beta 1, beta 2, beta 3, beta 4, beta 5 by the help of beta 0. So what can I write in place of beta 1? I can write lambda into beta 0. In place of beta 2, I can write lambda into lambda square into beta 0. Right, these were the values of beta 0s, beta 1 and beta 2, right? Beta 0 into lambda, beta 2 was beta 0 into lambda square, beta 3 was beta 0 into lambda cube. So I may write yt equals to alpha plus beta 0 xt. In place of beta 1 I may write beta 0 into lambda into xt minus this lambda looks like x, sorry, yes, lambda into xt minus 1, and then I am going to write in place of beta 2 I can write beta 0 into lambda square into xt minus 2, plus I may write some other lagged variables, but I am not going to write it here, plus ut. Here ut is the error term, right? Now if I want to calculate the yt, and if I want to this model is basically, if I want to calculate the parameters of the model, so basically here we can do some tricks, and which Koyck has suggested. So Koyck has suggested that suppose this is our equation 1, right? This is our equation 1. We will take 1 period lag of this equation, that is the equation will become now yt minus 1 equals to alpha plus beta 0 xt minus 1 plus beta 0 lambda xt minus sorry, I feel it is beta 0 xt minus 1, then beta 0 xt minus 2, beta 0 xt, sorry, yes, I have written a little wrong, beta 0 xt, then it should be beta 0 lambda xt minus 1, and then it should be beta 0 lambda square xt minus 2 plus ut. Now as we are taking lag of 1 period, so what is it becoming? Yt is becoming yt minus 1, so xt will also become xt minus 1, xt minus 1 will become xt minus 2, sorry, and t minus 2 will become xt minus 3, ut will become ut minus 1. Now suppose this is our equation 2, and we will basically do nothing, we will just subtract equation 1 from 2. So if we subtract 1 minus 2, then what we will get, and before subtracting we are just going to multiply lambda with equation 2. Okay, so basically what is happening here, if we multiply lambda, obviously we are going to multiply lambda on the both the sides, so it will be lambda alpha lambda beta 0 xt minus 1 lambda beta 0 xt minus 2. So this lambda and lambda will result us in lambda square in this case, and this will become lambda cube, this will become, and this will also take a lambda. Now if we subtract 1 and 2, what will we get? We will get yt minus lambda into yt minus 1 on the left hand side. And what will we get on the right hand side? Basically on the right hand side, at first on the equation 1 we have lambda, let me show you equation 1, we have alpha, and in the case of equation 2 we have lambda alpha. So we will basically alpha minus lambda alpha, and basically lambda beta 0 in the second equation. In the first equation we have lambda in the second equation we have lambda beta 0 xt minus 1, and in the first equation we have, as you can see, we have lambda beta 0 xt minus 1, right? So this will be subtracted, and the only term that will remain is beta 0 xt, right? So beta 0 xt is the only term that is remaining, all the other terms will be subtracted one by one, and this ut will remain, obviously this ut, and lambda into ut minus 1 will remain. So we will have lambda alpha minus lambda alpha plus this term which is going to remain in equation 1 beta 0 xt, because this term will not be subtracted. So beta 0 xt will remain, and ut will remain of the first equation, and in the second equation we have lambda ut minus 1 which will also remain. Okay, now this ut minus lambda into ut minus 1 can be represented as vt. So if I write it in the general form, I can write it as yt. I am just going to put yt on the one side and the yt minus 1 on the other side, lambda into yt minus 1 on the right hand side. I am going to take alpha common from here also, so it will be alpha into 1 minus lambda, and I am going to take lambda yt minus 1 on the right hand side, so it will become lambda yt minus 1, it will be positive, and then we will have beta 0 xt, and we have in the place of ut minus lambda ut minus 1 I am taking vt. Here vt is nothing but it is the moving average of ut and ut minus 1. You can write it also, moving average between ut and ut minus 1, moving average of ut minus 1. Now as we are heading to it, now the concept is, the process described here is basically Koyck transformation. So Koyck has made our things very simple. Koyck has actually transformed the equation in such a way that we don't have to depend on xt minus 1 or xt minus 2 or any other variables, any other lagged variables. We can actually estimate the model by the help of xt only, that is the current period variable. We just require the value of lambda, and we just require the value of yt minus 1, which is the previous period or lagged value of the dependent variable. Okay, now this model is basically an autoregressive model, because yt minus 1 is regressed upon yt is regressed upon yt minus 1, right? So that's why it is an autoregressive model, and as we have to say from this part that wireless estimation in this method will not be possible. Wireless estimation will not be directly possible because as you can see, yt minus 1, this is a in case of wireless estimation, the explanatory variable, that is yt minus 1 here, and the error term should be uncorrelated, right? But in case of yt minus 1, if you see the value of yt minus 1 in equation 2, yt minus 1 was basically consisting ut minus 1, right? And in vt we have ut minus 1, because vt is nothing but moving average of ut minus 1 and ut. So in vt we have ut minus 1, and in yt minus 1 we have ut minus 1. So the error term vt and yt minus 1 are not are correlated, basically here are correlated. So if we try to apply wireless estimation, right, in this particular case, if we try to apply wireless estimation, then there will be problems in calculating it, and there will be a bias that will arise. Okay, so that's how we apply Koyck transformation to a model. This is the equation of estimating the model.